Hello, this is Lorraine Jamison, and this is GoReact quiz number 14. So number 1 was to find the general solution of dx, this should be dt, equals x plus 2y, and then dy dt equals 4x plus 3y. So in this I use the formula x prime is equal to ax, where a is equal to 1, 2, 4, 3, because 1, 2, 4, 3. And then you take the determinant of a minus lambda I is equal to 0 in order to solve for the eigenvalues. So to take the determinant, you just cross multiply, and then you subtract this cross. So you have 1 minus lambda times the quantity of 3 minus lambda minus 8, because minus 8 here. And then you simplify that down to lambda minus 5. Lambda plus 1 is equal to your eigenvalues. So lambda 1 is equal to -1 and lambda 2 is equal to 5. It doesn't matter which way I did it. It's just I did it this way. And then you substitute back in to find k1 and k2. So lambda 1 is equal to -1. So 2, 2, and 4, 4 times k1, k2. So the k value, k1 is, or capital K1 is equal to 1, -1. And then the same thing with this second eigenvalue to find the eigenvector. You subtract 5 from the diagonal, so you have -4, 2, 4, -2. And then you get the eigenvector 1, 2, so k2 is equal to that. And so finally, the general solution is in the form of C1 times K1e to the negative lambda, or e to the lambda t. And lambda in the first case was -1, lambda in the second case was 5, and then this is K1 and this is K2. So in total, x is equal to C1 times K1, 1, -1, e to the negative t, plus C2 times the vector 1, 2, e to the 5t. And then here's problem 2. Once again, you're solving for the general solution. So dx dt is equal to 5x plus y, dy dt is equal to -2x plus 3y. So you just use the same sort of process where x prime is equal to ax, so 5, 1, 2, 3. You subtract the lambda to find the eigenvalues, and this does not factor nicely, so you have to use the quadratic formula. And you find that the quadratic formula gives 4 plus or minus I, and so lambda 1, lambda 2. So I called lambda 1 my 4 plus I because I know that I have to get to the negative value to use it in this equation. Set it equal to 0, so k1 is equal to -1 or minus I, 2. And then just using this formula, C1 e to the alpha t times the quantity of b1 cosine beta t minus b2 sine beta t plus c2 e to the alpha t b2 cos beta t plus b1 sine beta t. And so this is where b1 is equal to the real part of this equation and b2 is equal to the imaginary part. So the real part of this is -1, 2, and then the imaginary part is -1, and then this would be like saying 0 plus 0 I, so -1, 0. Alpha in this case is 4, because that is lambdas in the form of alpha plus beta I. And so that means that, oh, frick. Okay, so I realized I had made a mistake here. Beta should have been 1, not a -1. And that comes from the fact that this lambda is 1I and non-1I. So anyways, nonetheless, beta is equal to 1, and then we have the real and the imaginary part. So you just plug all of those into the equation, being C1 e to the 4t times the quantity of -1, 2 cosine t minus -1, 0 sine t plus C2 e to the 4t times -1, 0 cosine t plus 1, 2 sine t. Thank you.